Welcome, welcome, welcome to Physical Science. I'm Miss Lisa, and this is my YouTube channel. And I want you to like, share, and subscribe because I want this to be easier for me. And if I can get enough subscribers, then YouTube will let me go live and it'll be easier. So I'm lazy and I want to do it the easy way. And I want this class to bless lots of people so that way it can bless more people if you share it with your homeschool friends. Now, this class is physical science. It is primarily designed for homeschoolers who need a high school science credit. But if you like the way I explain things and you're taking physical science from somebody else, you can watch whatever topic it is and it can be useful for you too. But if you're a homeschooler, you can take this as your class. We will be going through it for this year, and I'll leave the videos up so you can show it to kids for years to come. We're going to be using 2 books, and I'll write the book numbers in the description, the ISBN number. Our primary text is going to be this one. It's Glencoe Physical Science. The reason why we're going to use this, and this is different than when I did the introduction video, is because it's a newer edition and it reads really well. It's really a good edition. So this is going to be our primary text, but we're also going to use this one, and we're going to use this one because this is a class primarily designed for homeschoolers, and it will have a lab component. The labs in this book are most of them are very easy to do with readily available non-sciencey stuff. I mean, it might call for beakers, but I'll write in the description, yeah, you can use a cup, whatever it is. But this one has better labs that are just easy to do for take-home labs. So this all started because I was teaching homeschoolers and COVID hit. This is 2020, and everybody had to go home, and so everything became distance education. And I realized that these have really good take-home labs. So that's one reason why we're doing this. So anyway, I ended up having to record the classes because of COVID. And over the summer, I did the math classes because I had math kids doing summer school. And I thought I can go ahead and put them up on YouTube and then they'll be ready for the next year. And then I wasn't going to do science because my science videos that I'd had before had kids in them, and I can't put kids on YouTube. But then I figured out an easier way to do it. So I decided to go ahead and re-record the science classes this fall. They'll be on there for a long time and people can use them for a long time. So anyway, that's why I'm recording these classes, just to bless the homeschool community. And I know some of you are groaning because there's 2 books, but these are both old books and you should be able to get them pretty cheap off of, I think you say it, Alibris. I always want to say Alibris, but I think it's Alibris, eBay, and Amazon, and I'll put the book numbers there. So, but this one we'll be using some, and actually some of our tests might be this edition. Now, so your homework I will assign to you in the comments. See, whatever's in the comments is what I want you to do. There are about 25 chapters in this book. We'll roughly do 1 a week, but a school year is like 38, 40 weeks. But I expect you as homeschoolers to take field trips. There'll be weeks that you will not do your physical science video. It'll be here for you, but you're going to want to go, or if you're in the Atlanta area, to Fernbank and go to the science center where you can actually do a lot of the experiments that you're not going to be able to do because you don't have the equipment. At Fernbank in Atlanta, they have a whole area for physical science experiments, and you'll be able to do a lot of them. So if you live somewhere else, I bet there's a science center near you. So I would like it. And if you got the big bucks, you might even want to join and become a member and be able to come back and do science experiments a lot, not try to do it all in one day. One day just do the light stuff, and one day do the magnetism stuff, and one day do, the thing about the weather and stuff, and then come back another day. Because most metropolitan areas have a science center now that has a physical science room where you can do labs. So I highly encourage you to incorporate that I think the best science is science you do, that's hands-on, and it helps put it in that long-term memory. I always say, don't make science another reading comprehension class. You've got it in reading, you've got it in social studies and in history. Don't make science another reading comprehension class. You learn science by doing science. So I want you to do science this year, so you'll have lab assignments also. All right, so also about how the course works is you'll watch the video, always watch the video. This summer in summer school, I had people saying, Miss Blackburn, I don't know how to do this math. And I'm like, did you watch the video? Because I can go and look and see everybody hasn't watched the video. No, I didn't get around to that. Well, go watch the video. So that's how you're going to be able to learn it, not just from reading the book. And hopefully the videos will be interesting and maybe even fun. Sorry about my voice. It is hoarse because the ragweed is blooming season. I always lose it this time of year. It doesn't bother me. It doesn't hurt, but it sounds awful for you. There are some of y'all out there going, I cannot listen to this woman for a year with that voice, but it should get better. It always does. As soon as the ragweed quits blooming. Sometimes it takes longer than others, but maybe this year it won't be bad. Okay, so if you've got the book, go ahead and turn with me in this book to chapter 1. Let me tell you one more thing to the moms. There is a Facebook page. This is to be a Miss Lisa. It's Mrs. Lisa. And it has tests and answers on it that will go along with this class. So kids can't join because there are tests and answers on the Facebook group. But you can join and have support. You can even get together with other people in your area and do labs together. And but also the tests and the answers are on there. All right, so let's go ahead and talk about chapter 1. This video will be a little longer than usual because I had to talk about the background stuff. I'm hoping in the future they'll only be about 30 minutes. This one when I just did chemistry and biology, and those were about 40 minutes. So hopefully I'll be able to trim it down. It'll be 30 minutes or less going forward. We will see. All right, so look in your book, and it talks about what is science. Science comes from the Latin word that means knowledge. Scientia. I'm sure I said that in perfect ancient Latin. So there are 3 major categories of science. There's life science, like biology and zoology, all the things that deal with living things. There's earth science that deals with, that's right, the earth. And then what we're going to study is called physical science, and it is chemistry and physics. It's the physical world, not the living stuff. So, and in this class, physical science, we'll learn some chemistry and some physics. We're going to do the physics first and then the chemistry because that's the order of your book. And but it can be done in either order. This book, one of the things I don't like about the one we're using for lab is they jump. They do chemistry, physics, chemistry, physics. So I like this other book that we're using as our primary book because it does physics, boom, chemistry. Makes more sense to me. But studies have shown students who go on to take chemistry and physics after physical science do better. So this could be just a standalone class, or like you might not ever plan on taking physics, that's okay. But if you do, this is a great introduction class. So that's what physical science is. Now, science explains nature. How we do science is experiments, investigations. And how we do that is, yes, you guessed it, the scientific method. My son Eli was like, Mom, that's just a waste of time. Why do you have to talk about the scientific method every single time you do a science class? I'm like, well, because it's what it's all based on. So we're going to talk about the scientific method again, if you've heard it. But if not, that's all right. So I didn't tell you my background. I'm a former public school teacher who became a homeschool mom who is now going back to public school teaching. So that's why, and when my kids got the age, other homeschool moms would always beg me, teach science and math to my kids. But I didn't have time when my kids were little homeschoolers. But once they got to be high school age, I went ahead and opened it up where other kids could join us and learn science and math while I taught it to my kids. And but now my last little bird is going to college, getting out of the nest, and I don't have to homeschool them anymore. So I went back to public school teaching, and so I'm not going to be doing the homeschool classes anymore. So I'm putting them on YouTube, and that way homeschoolers can continue to learn science and math from me for years to come. Years and years. You can watch these videos. They'll be on YouTube. So scientific method. So scientific methods. Real scientists don't necessarily follow it. I want to discover something today. Step 1. Think of a question or observe a problem. And step 2, do some research. Step 3, design an experiment that has a control and variables. Step 4, generate some data. Step 5, come to a conclusion. Step 6, I left out hypothesis. Well, once you look at your problem or your question, then that leads you to an idea, your hypothesis, that then needs to be testable. That's because I was going off my memory, and this is the third time I've done it today. It seems like you should already know it, but no, this is the first time for you. Anyway, then you come to a conclusion, and you can it could be that your hypothesis was wrong, throw it out, or it could be it needs more testing, test it some more. So it can lead to further investigation, more questions, more experiments. Now, what I was saying is, real scientists don't necessarily go step 1, step 2, step 3, but real scientists do conduct science in a very orderly, controlled way. You do not change more than one thing at a time in an experiment, or you won't know what it was that had the effect. You want to have a control, something to compare it to. A lot of things in science have been discovered by accident. They really didn't start out step 1, step 2, but they looked at the accident through what I call their science goggles, and they looked at it and thought, what is going on here? And they started figuring it out and figuring out experiments that they could do to then understand it better. So it's not as rigorous and cut and dry as middle school and high school books make it look, but it is controlled and observable and repeatable. Those are the things you want. Now, I know that, and in the science lab, I'm very disciplined about that. But when it comes to me getting sick, boom, all that's out the window. I will try everything someone suggests. Someone says drink more vitamin C, yes. Someone says, take this vitamin, yes. Rub this essential oil quick. I will rub it on me, whatever it is, because I just want to get well. Then when I get well, I don't know which one helped because I tried them all. One time I was tutoring in the library, some homeschool kids, and I didn't feel real good. And one of the moms came up to me and said, Lisa, you look terrible. Are you feeling okay? I'm like, no, I think I'm getting a cold. She said, oh, I just bought something at Kroger. And she hands me a handful of yellow pills. And I didn't even know what they were, and I took them. Now, you should not take pills that people give you unless you really trust them. But I really trusted this homeschool mom, and I just took the pill. And I got better. I don't know if it was that pill or not. But the funny thing about it is I took the rest of the pills, and I threw them in my pencil box that has like my pencils and calculator cables and ruler in it. And I just threw it in there. And just for years, they were in there because I got well and I didn't know what they were and I didn't want to keep taking them. And they would drive my cats crazy. My cats wanted to smell those pills so bad and wanted to eat them. So I don't know what they were, but my hypothesis is that it was catnip. But there's no way to test it because, well, I guess there is. But I don't know if I have any of them anymore. But if I did, I guess I could take them to a lab and figure out what were the yellow pills. They might work though, because I got better. So when you have so you're going to read this chapter carefully, and you've probably had the scientific method before if you are high school level. But one of the things I want to mention that's in the other book that will be in your lab is, as scientists, we make observations. And it could be direct observations that use your 5 senses: seeing, hearing, smelling, touching, tasting. Now, in good science, we don't taste unless we absolutely know what it is. If you work for a food company, then yeah, people will taste the new products and stuff. But in the regular chem lab, no tasting your experiment. You will die. You will not get superpowers. I know it's disappointing, but it's true. So those are direct observations. You're going to do a lab on this. indirect observations is things that you do with where you can use an instrument. If you take a ruler and measure it, or if you take a scale and measure it, if you put it in an MRI machine and use some instrument, then that is an indirect observation. So, I'll explain the lab probably in the comments. But what you're going to do is you're going to observe some white powder. So your mom is going to go find something white, and you're going to try to figure out what it is. So moms, it could be a piece of chalk, it could be some flour, it could be some sugar. Find something around your house that's a white powder that's not harmful. Don't go get the fertilizer or anything. Go find something in the kitchen and see if your kid can use their powers of observation to figure out what it is. That'll be the lab we'll be doing out of the other book, the book that we could call the bubble book because it has bubbles on it, rainbow bubbles. That sounds fun. All right, so we want to be objective, and one of the things about being objective as scientists is we want to observe, and we want to make sure that we don't confuse observation and inference. Observation is what you just are observing. Inference is the conclusions you make for it. So I do this demonstration, if you were in class physical science, where I light a candle, a homemade candle. And as the kids are observing, they're writing down what color the flame is, all of that. I light it and then I eat it and it crunches. So then they go. So they always then infer and they'll say, it was an apple. And see, is that an observation or an inference? It's an inference. They're guessing it was really an apple, but in fact, it's not really an apple. But what they observed is when I bite it, it crunches. And so then they can say, well, they could write down the observation, it crunches. They could write down the conclusion or the inference is that it's an apple. It's an apple is not an observation, it's a conclusion. So as scientists, we have to be real careful that we don't jump to conclusions. We also want to watch out for bias. There's a lot of dishonesty in science right now. Every year you hear of scientists who have to retract their experiment because they got caught lying about the data. Why do they lie about the data? Because there's money in science, and if they can get more grants and research money, if they discover something great and their experiment is successful, than if it's not. So every year you hear about scientists who have to admit, nope, we lied, that we didn't really discover what we did. And it's crazy. Their reputation is going to be over. Their career is going to be ruined. And it's so much better to just admit, nope, this did not work. We need to do something else than to ruin your career for getting caught lying and faking data. But every single year it makes the news at least once. All right, so what is a model in science? Well, you know what like a model airplane is? Well, in science, it's more than just something that like you can have you go to the dentist and they have a model of your tooth and your little tooth is big. Or you can have something big like the world and you can have a globe of it, which is little. So in our common speech, we think of a model as something bigger or smaller than it is in real life. In science, though, it can even be a way to explain things. So a model it could be like that, the atom is like, at one time they thought that the way an atom works is like the planets. It was the planetary model of the atom, and it was that they felt like the nucleus was like the sun, and the electrons were like the planets going in orbits around the sun. They thought the electrons went in orbits around the nucleus, and they kind of do, but now we know more about it, and we know they hang out more in clouds, and that they have energy levels, so our model has changed. But it can be just a way to explain something in science can be called a model. Nowadays, we use a lot of computers and high-tech models. Now, what's a theory and a law? If you have an experiment that has been performed over and over and over again and you keep learning more and more about it, then it can become a scientific theory. Scientific theories are true. The example I always use is the atomic theory of matter. It is the theory that everything is made out of atoms. Is everything made out of atoms? Absolutely, we know it's true. John Dalton thought of it hundreds of years ago, and he said that the atom was like a billiard ball, a pool ball, and that it was indivisible. In fact, the word atom means indivisible. You could say it in the pledge. I pledge allegiance to the flag of the United States of America, one nation, under God, atom, for liberty and justice for all. Indivisible, with liberty and justice for all. But we know now that it's a little different. It has changed. Now we know that yes, the atom is the smallest piece of matter that has the properties of the matter. So if you had one gold atom, it would be yellow and shiny and conduct electricity and heat. It would have the properties of gold. But now we know that the atom is divisible. It can be made, you can split the atom, you can have the atom bomb. So we know that the atom can be split, and we know that it is made out of protons, neutrons, and electrons. But protons, neutrons, and electrons are all the same. It's like Lego bricks that you can put them together and make different things. The bricks don't have the characteristic. What you put it into has the characteristic. So the atomic theory of matter is true, but it changes. So it's not like when it grows up, it's going to get to be the atomic law of matter. It will always be a theory because we're always learning more about it. We're still learning more about it. There's something called dark matter that we don't know everything about, and there's lots of speculation about, and so we're learning more and more about the atom. Now, the difference, the problem is theory is something in common everyday speech. I have my fruitcake theory, which is nobody really likes fruitcake. I'd never met anybody who liked fruitcake. My idea was people just re-gift it because it's full of alcohol and sugar. That stuff will last forever. It's well preserved. Nobody likes fruitcake. They just re-gifted. All the fruitcake that has ever been made, they quit making it in the 50s, and ever since then, people are giving it to each other. That's the common everyday use of the word theory. It is not the scientific use. In science, theories, you can think of them as true. Now, turns out that my theory was wrong. I met a girl who likes fruitcake, and she told me I would like her grandmama's fruitcake. I never tried it, so I still don't like fruitcake. It only takes one example to knock something in science out. Once I met that girl who said, nope, she's seen people make fruitcakes, she likes fruitcakes, my theory was gone. But my theory is the everyday language. I have a theory about aliens. Whatever it is, you can have a theory about it. It's not a scientific theory. One problem with the word theory is we will use the everyday language word theory in science when we're not talking about a scientific theory. For something to be a real scientific theory, it must be observable and testable. We have to be able to have a test and observe it right now. So if it's something about the past, we might have a common speech theory about it, but it's not the theory in the scientific sense because we have not done thousands of experiments to prove it. So it's confusing, I know. Laws are easier to understand. Laws are, read the definition in the book, but what I have found helps students kind of get it in their head, what is laws are so true they're math. Laws have mathematical equations associated with them and usually a constant. So gravity is not the theory of gravity, it's the law of gravity. There is a mathematic physics equation that goes with it and a constant. The acceleration due to gravity is 9.8 meters per second squared. So when you learn physics, you'll learn more about the laws and you'll learn about the math because physics, you do lots of math. In physical science, we're going to learn some of the concepts of physics, but without so much math. Come back to physics for the math. All right. Science has limitations. I told you that we don't understand dark matter. Sometimes kids really get the wrong impression thinking scientists know everything. And they'll say, well, it's the science. But remember, science is always changing. We're always learning. And we tend to laugh at what scientists used to think. Ha, ha, ha. They were so silly. They thought that Cold was a fluid that could fly through the air and get into you. And now we know cold is just the absence of heat. So science changes, and what we think now will be laughed at later. Some of it will be true, but some of it is going to get tossed out of there. Technology is very important for science. Technology is sort of the application of science, and it's used to advance science. A lot of times technology comes first, and then science will follow that. Units in science. Okay, so you have grown up in America with 2 unit systems, both equally used. The English or empirical system is feet, inches, Fahrenheit degrees, miles, cups, ounces, pounds, all of those units. We also have the metric system, or SI, in our country. Those two are slightly different, but a lot of overlap. Things like liters, you buy your Coke in liters, you're used to that. You buy your milk in gallons, which is the English system. We have both in our country, and I have found that kids know neither. When I was a kid growing up in the 70s and 80s, English was the regular one, metric was the weird one, and we could kind of keep them straight. Because you kids have grown up with both of the 2 systems equally, I have found as a teacher that it's just gobbledygook in your heads. So I'm going to try to be the queen of math and science. I don't know how, because it's not a real position. But when we do, then my idea is that we use English for every day. Gallons, inches, Fahrenheit degrees, and that we just use metric or SI for science, because this whole thing of having 2 systems is not working for the young generation. I used to say that when they make me queen of math and science, we're going to metric at midnight. They both start with M. It sounds good. But I've been watching the Great British Bake Off, and the metric system does not work for them. They don't really weigh themselves in kilograms. They say it in stones. It's very awkward with them cooking with the metric system. And I think English is just a lot more natural for an everyday system. I was talking to some of the public school kids that I teach, and one guy said it's because they have big, big things and little bitty things and not good measurements of in between. And he's right. You've got meters, and then you've got centimeters, which are as big as your pinky across, and then millimeters, which is as close as you can get your fingers without touching. But they don't have the foot. They don't have the inch. They're just missing some very handy measurements. So that's my new campaign. I don't know how this is going to work out for me. Maybe I need to talk to the president, because I don't think I'm going to win this at all. But I can always dream, right? 1,000 subscribers and queen of math and science. I had a student last year who he said he was going to bring me a tiara, because even if I can't be queen of math and science, I can just at least have a tiara. But then COVID hit, and I didn't get a tiara. I guess my reading glasses is my tiara. All right, so how the metric system works. Look on page 15. It has base units like the meter, the kilogram, the second, the amp, the ampere, Kelvin, or Celsius degrees, mole, candela, and then you have prefixes. So let's just talk about length. The unit of length is the meter, which is 3 inches more than a yard for people who understand English better. And then you add prefixes to make a bigger or smaller measurement. So if you want to measure a distance between cities, you don't measure it in meters, you measure it in 1,000 meters, which is kilometer or kilometer. Kilo means 1,000. If you want to measure a worm, you don't measure it in a big old meter, you measure it in centimeters. Centi means 100th. Or if you want to measure a gnat, you would measure him in millimeters, because milli is 1,000. So I've got a board here ready to teach it to you. I'll scoot over. So these are some metric bases: gram, liter, meter. It could be a second, it could be a Celsius degree, something like that. And that's your basic unit. If it's a tenth of it, it's deci. So if we do liters, it's a deciliter, or centi is centiliter, or milli a milliliter. If you have 10 of them, it's a deca. 100 is hecto. 1,000, I left a zero off. I got all thinking about the spacing. Let's fix it. 1,000 is kilo or kilo. Okay, so you put the prefix with the base and you get the unit. It's very easy with metric to change between units. Let me show you. If I have 42 millimeters and I want to know how many decameters it is, all I have to do is count how many times a frog would hop between those two. 1, 2, 3, 4. I take my decimal point and I move it the same number of hops in the same direction. I call this the frog hop method. So here is my decimal point at 42. It's Kermit the Frog or the Frog Prince. I love that movie on Disney. 1, 2, 3, 4, Princess and the Frog. The decimal point goes here. I augment zeros. Remember that from division in 3rd, 4th grade. And the answer is, if I'm changing millimeters to decameters, is 0.0042 decameters. If I want to change, like this is a problem in your book, 3,075 millimeters to centimeters, it's 1 frog hop. I move the decimal point over 1 place, is 307.5. And that's why metric's better. It's because that's so easy. Now, how I get kids to remember this is it's King Henry's daughter bakes delicious chocolate muffins. You have to think about the muffins, how delicious they are. In my head, they're chocolate muffin with chocolate chips, with butter and coffee. But for you imagine them how you want, but really think about it so you can remember it. And as long as it's from kilo to milli, all you have to do is frog hop. Now in your book, on page 15, they show you some other ones. They show you micro and nano, and those don't fit on the frog hop so well. So I'm going to show you how to change 3 million micrograms to grams. What you do is you first write down how many you start with. 3 million micrograms. Isn't that an interesting symbol? And then you write micrograms on the bottom down here. Because in math, if you have the same thing in the numerator and denominator, you get to cancel them out. And I want micrograms to be gone away and be left with grams. You write what you want to change it to in the numerator up here. And then you write the relationship. And we can tell from our chart on page 15 that a microgram, its conversion factor is 0.000001. So I write that number that goes with it next to it and 1 next to gram. Any number on top I multiply, any number on bottom I divide. So I do 3 million times 1 divided by this. You don't really have to multiply or divide by 1 because any number multiplied or divided by 1 is itself, but it doesn't hurt to do it either. So you can do it if you want. But if you understand the math of that, you can skip that. Okay, so try it on your calculator. You need a scientific calculator for this class, not just your phone, because if it's a test, the Google is on your phone, which would have all the answers, and that'd be cheating. It'd be very tempting to cheat. So try to get a scientific calculator. It needs to have the button EE or EXP, so look for that. A cheap one is the TI-30X Scientific. It's about $12 at Walmart and Target. So get a scientific calculator, practice this. Whenever I do math, pause the video, practice it, and then come back. I can be paused, but come back. Don't just pause and go play with your dog or whatever. All right, so now you're back. Welcome back, welcome back. And you can look at how they do the problem. They set it up a little different than me in that they didn't frog hop when they could have. They set it up the other way, which is a unit conversion. It's also called dimensional analysis. That you can look at the units and figure out how to do the problem. I like drawing the straight lines the way I did better than the parentheses they do because I've taught for decades. We're not going to talk about how many. And kids will get messy with those parentheses and they'll start being sixes and the railroad tracks. I know it doesn't really look like railroad tracks. It looks more like Frankenstein stitches. But the railroad tracks help keep the kids a little neater and they get the answer more often. So I want you to use the railroad tracks like I did in the example. All right, we measure distances in meter. Volume can be measured, look on page 18. with measuring length times width times height and multiplying them together. That gives you the volume like of a cube. There's also a formula for volume of a cylinder. If it's a liquid, we measure it in a tube called a graduated cylinder. And the units of that are milliliters. We measure in liters for liquid volume. The relationship between the length times width times height is that if you had a little box and it was 1 centimeter on each side, a centimeter tall, a centimeter wide, a centimeter high, and then you could fill it up with water. It would take about 10 drops, and that amount of water that's in that box is called a milliliter. It's the same thing as a cc or a cubic centimeter. In medicine, they use cc. Give me 50 cc's of adrenaline stat. But in science, we usually use milliliters. In geometry, we also use those cubic centimeters because we will measure the length, the width, and the height. And you multiply them together, and it tells you how much you can put in it, how much you can put in the box. When you measure matter, you measure it in grams. You get its mass in grams. The density is sort of a derived thing. It's mass divided by volume. So if we wanted my density, I would be weighed. We won't talk about how much. And then you would get my volume, and how you could get that is by me submerging in water, and how much the water goes up is my volume. It's how Archimedes figured out. He figured this out. There's a legend of Archimedes with this. So density, the units of density is a mass unit divided by a volume unit, like grams per milliliter. You measure time in English and metric the same. It's in seconds. Temperature is measured in metric in Celsius degrees, in SI in Kelvin, and in English in Fahrenheit degrees. Usually in science class we use Celsius degrees, except in chemistry we will do gas laws and use Kelvin. A Kelvin degree and a Celsius degree is the same. The difference is where you start. Kelvin starts at 0 and its absolute value is where all matter motion ceases. If you could see the atoms in any solid around you, they're vibrating because they have heat, they have temperature. I mean, temperature is the measure of heat, but they are vibrating. You cool it down, cool it down, cool it down until the atoms quit vibrating. That's absolute 0. It's way below 0 in Celsius and Fahrenheit. So Kelvin has no negative numbers. Celsius does. Celsius is based on water. In Celsius, water boils at 100 and it freezes at 0. In English, water freezes at 32 and boils at 212. So regularly in the lab, we use Celsius, and that's our main one for temperature. Okay, so you can read about those. How we communicate in science is a lot of different ways, but the one we're going to talk about today is graphs. Reading your book, and you can read about that you can have a line graph, a bar graph, a circle graph. All graphs you want to be neat with, and also you can actually have a graphing calculator that will do your graphing for you. A lot of scientists nowadays use computers to generate their graphs, but there's a little rule about graphing is if you have something that you're graphing, it has what is called a dependent and independent variable. The independent variable can't be changed. It's something like time. There's nothing we can do to change time, is there? The dependent variable is what we are doing the experiment on. And when you do your graph for an experiment, you put the independent variable, like time, always goes on the bottom, and the dependent variable, the thing you're doing the experiment on, it goes on the side here. The bottom is called the x-axis, the side is called the y-axis. So that's just a little rule about how to do graphs. I remember I missed that. I had a concussion in 9th grade. I had a very hard time learning some of these algebra concepts. So read your chapter, look at the description of this video, and it will tell you what I want you to do for homework. And come back next week and we'll learn more science. Science is great.